Kirchoff law I've given you in the last class, number 3. So here first thing you have to do, first is the diagram first. This is a cell 6 volt, this is the internal resistance 2 ohms, 8 volt cell EMF is the internal resistance, 2 volts is 2 ohm resistance, internal resistance. There the external resistance are mentioned, there the current direction are given. So at the point P, if you see, current is coming in like this, all currents are coming towards it, so no current is going out. So algebraic sum should be like this, because no outward current, that's why 0, and they all are inward currents. So I can assume I3 to be minus I1 plus I2. Okay, this is required. This is from Kirchoff first law or KCL, Kirchoff current law. Alright, so I'm writing down here I3 equals to minus I1 plus I2. This is required. Now we go to straight to the Kirchoff voltage law. Now you see, to consider two loops. First loop is, loop name is ABFE. ABFE loop. You can see this 8 volt is giving current that direction, and 6 volt is giving current this direction. So now 8 volt is giving current anti-clockwise, so plus 8, and 6 volt is giving clockwise current, so minus 6 this side. Now this side, that means you are getting net EMF this side. So anti-clockwise positive, clockwise negative. Next, the direction of current. So I1 automatically is positive, sorry, it is negative because clockwise direction. So minus I1 into 4. Next, plus I2 into 1 because anti-clockwise direction. Here you have 2 ohm resistance, internal resistance, that's why I1 into 2, because current also going to the internal resistance also. And next, I2 into 1 plus. This is the equation for loop ABFE. So 4I1 minus 2I1 plus I2. 6I1 2I2 minus 6I1. That is the value of, this is the first equation, 6I1 minus 2I2 equals to 2. Okay, so I'm writing down in the equation over here. Next, in the loop BCED, or you can say BCD. In this loop, this 8 volt is giving clockwise current, so minus 8, but 2 volt is giving anti-clockwise current, so plus 2. Here I2 is giving us current clockwise direction, that direction, so that's why 1 I2 minus 1 for the internal resistance I2. You can see that means I2 in the previous ABFE anti-clockwise, sorry, I2 is anti-clockwise, but here I2 is clockwise, so it can vary depending on the circuit. And here 2 volt, that means I3 automatically here it is plus I3 into 2, and next plus I3 into 2 is positive, so it is minus 6 2I2 plus 4I3 equals to minus 6. So here you can write minus 6 equals to 4I3 minus 2I2. Now if you put the value of I3 equals to with negative sign, I am using this one. So we are getting minus 6 2i2 minus 4i1 minus 4i2. So finally 6 2 4 2 6 6i2 plus minus 4i1 equals to 6. So dividing by 2 both side and taking just cancelling minus sign, 2i1 plus 3i2 equals to 6 is the ultimate equation you require. So I'm just writing down here 2i1 plus 3i2 equals to 6. This is the third equation, you can see, right? So now I have to solve it to get the equation of I1 and I2. So here I'm multiplying it with 3. So I'm getting 6i1 plus 9i2 equals to 18. This procedure you know, I think. By 11. And what about I1? I1 you can find out any of the equations. You put, for example, 2 into I1 plus 3 16 by 11 equal to 6. So 2i1 is nothing but 6 minus 48 by 11. So 2i1 equals to 66 minus 48 by 11. So I1 is 18 by 11 divided by 2, that is 9 by 11 ampere. This is also ampere. And what about I3? I3 is minus I1 plus I2. So minus 16 by 11 plus 9 by 11. So 25 by 11 ampere is the value of current. So actually minus sign suggesting that direction of I2, I3 should be in opposite direction. That means it should be in that direction. So I have taken that direction, there is no problem. But if you take an opposite direction current or wrong direction of current, it will come negative sign. So hence I have solved that numerical number 3. I think it is clear to everyone.